Hi, welcome to Solving Distance Word Problems. Solving distance word problems in two variables is similar to what we did with age. We'll create a grid, but let's solve a couple and see what happens, see if you're okay with them. Leaving the same time on the same highway, two cars 900 miles apart travel towards each other and meet after 5 hours. Their speeds differ by 20 miles per hour. Find their speeds. Well, distance equals rate times time. So what we have is we have two cars. So let's say we label the cars as car A and car B. So we'll have a speed and we have time, because rate times time gives me distance. So we'll create these columns. A good way to do it so you don't have to write a lot of words out. And they leave, let's see, they leave at the same time, travel on the same highway, they meet after 5 hours. So that means they're both traveling for 5 hours, and their distance traveled is 900, but let's write an expression for their speeds differ by 20. So let's let the speed of car A be x and the speed of car B be y. So now let's get the distance. So the distance of car A is rate times time, or time is 5x, because x times 5 is 5x. Rate times time is y times 5 is 5y. So as a result, one equation could be the distance traveled. So if you imagine two cars, here's A and here's car B, and they leave and they drive towards each other. So that means between the two of them, the distances are adding up. So the car A travels that 5x, car B travels 5y, and together they're going to add up to give you 900. And their speeds differ by 20. So if their speeds differ by 20, that means we can say x minus y equals 20. So we have two equations, 1 and 2. So because I have them written out like that, which is ax plus by equals c, I'll multiply this one by negative 5 and this one by 1. That gives me 5x plus 5y equals 900. Multiply this one by negative 5 and I get negative 5x minus plus 5y. Notice a negative times a positive is a negative. Negative times a negative is a positive. I almost made a little error then. So that gives me negative 5 times 20 is a negative 100. And I am eliminating the x's. So the y, 10y equals 800. Divide by 10. Divide by 10, not 18, 10. 10's cancel, I get y equals 80. And if you go over here, let's put this equation, let's sub 80 4y into. Now I can go into this equation or into this one, but notice this equation is easier to deal with, so I'm going to put it into number 2. So x minus y equals 20. So y is 80. So x is 20 plus 80. So x is 100. So cars, car A is x. Car A is 100 miles per hour. And car B is 80 miles per hour, because x is car A and y is car B. Okay, let's do another one. A plane flew with the wind 2,200 kilometers in 4 hours. Against the same wind speed, it flew 2,700 kilometers in 6 hours. Find the speed of the wind and the speed of the plane in still air. Well, the reason it's still air is because if the plane had flying with no wind blowing, then that would be in still air. But when it's driving with the wind, it's the speed of the plane plus the wind. When it's driving against the wind or flying against the wind, it's the speed of the plane minus the wind. So this chart that I'm going to use is going to be a little bit different because I'm going to have it with the wind and against the wind. I find this is the better way to do this one. So I have speed, time, and distance, because distance equals rate times time. Let's finish that off. So what we're going to do is that in this chart, I'm going to let P be the speed of the plane in still air, and let W be the speed of the wind. So I do that up here. I wrote it in this chart, but with this one with the wind against it, I didn't put which one was with what. I had to make this statement. That's the way I find doing it easier. So the speed with the wind is the plane plus the wind. The speed against the wind is the plane minus the wind. So the plane flew with the wind 2,200 kilometers in 4 hours. So 4 hours, it flew 2,200. And against the wind, it flew 2,700 in 6 hours. So 6 hours with 2,700. So that gives us two equations. And the two equations, notice that distance is rate times time, but also the distance could be time times rate. So because I could write down 2,000 or 4 times, what I'm going to do is put 4 in front of the rate equals to 22. Again, I could have put P plus W times 4, rate times time equals this, but I like to put the monomial in front of these two binomials. And 6 is the time times the rate gives me the 2,700. So putting the 4 and the 6 in front of the rate makes the problem easier. And these problems can be done quickly. If you divide by 4, you get P plus W. And if you divide by 4 here, you get 550. Divide by 6, you get P minus W. And divide by 6 into 2,700, you get 450. And when you do that, because this is a quick way of doing it, then the W's cancel and you get 2P equals 1,000. Divide by 2, so P becomes 500. So the plane is going at 500. So which equation do you want to go into? Well, I would sub 500 4P, which is the plane, into, and I would go into this equation right here. I would put it into P plus W equals 550, because 500 plus W equals 550. So W is 550 minus 500. So that means you go up here, W is 50. So to finish the problem off, you get the plane has a speed of, plane speed is 500, and we have kilometers per hour, and the wind speed is 50 kilometers per hour. So this, you could multiply this equation by 4 and get 4p plus 4w. Multiply this one by 6 and get 6p minus 6w. But you have to do an elimination then. It's easier to divide by 4 and divide by 6 to get the simple equation here. That's a little trick that you do it against current and against the wind, etc., etc. Okay, we have 2 more to do, and you can practice. Practice means you can pause the video and work these out beforehand to see if you can get the correct answers, and press play and see if you're doing okay. So a boat went downstream 45 kilometers for 3 hours. It returned to the starting position. To turn to the starting position took 5 hours. Find the speed of the current and the speed of the boat in still water. Again, the speed of the boat without any current, but when you go with the current is a plus, when you go against the current is a minus. So we have with current and against the current. So we have, what we have is, we have a boat and we speed, so we have to let, I'm going to let B be the speed of the boat in still water, and I'm going to let C be the speed of the current. R-R-E-N-T, right. So we have speed, time, and distance. Again, rate times time gives me distance. So let's read the problem. Let's look it over. We got against the current. So the speed with the current is the boat plus the current. The speed against the current is the boat minus the current. Again, you wouldn't reverse. This one you could reverse, but you can't reverse this one. Because if you did, if you took the current and subtract the boat, you get a negative. So with the current, it's going downstream with the current. It's going for 3 hours. And the distance is 45. The distance is 45. And it says returns to the starting position, so that means it's going 45. It goes down 45 and up 45, and it's going to take 5 hours to go back up, which makes sense. You go down faster, you come back slower. So the two equations are, again, rate, distance equals rate times time. But when I write this set out, I like to put the time and the rate. I like to put 3 in front of the rate to give me the distance. I like to put the 5, which is the time, in front of the rate to give me the distance. So rate times time gives me 45, but put the 3 in front. It's better. Rate times time gives me 45, but put the 5 in front. Reason? Because they work out, these problems work out nicely. Divide by 3, you get B plus C equals 15. Divide by 3, 3's cancel. Divide by 3, I get 15. Divide by 5, the 5's cancel, I get B minus C. And divide by 5, and I get 9. Draw a line. The C's cancel out. 2B equals 24. B equals 12. Now, I'm going to sub 12 for B into. And the equation that I like to write down, again, is the one with the plus. B plus C equals 15. So B is 12, so 12 plus C is 15. C is 15 minus 12. C is 3. So the boat has a speed of 12, and this is, let's see, miles, kilometers. So it's kilometers per hour. And the current is 3 kilometers per, as an H there, hour. And again, if you check it back and go 12 plus 3 is 15, times 3 is 45. 15 subtract 3 is 9. 5 nines are 45, so it checks out. And we have another one to do. Find from the same town, trucks A and B travel south on the same road. Truck A leaves 2 hours before truck B. Truck B travels for 6 hours at the speed of 40 kilometers faster. If truck B is 60 miles further from town than truck A, find their speed. So you got to be careful. This one's a little bit more heavier. So what we can do is say, this is the trucks, this is the speed, this is the time, and this is the distance, because distance equals rate times time. So we have a truck A and we have a truck B. So what I'm doing this time, I'm going to say truck A got a speed of A and truck B got a speed of B. I could use X's and Y's. Now, let me explain what's happening here. So imagine that here's the town. That's the town that both trucks are leaving for. So truck A starts out. Truck A leaves 2 hours before truck B. So truck A is leaving. So this is A, truck A, and this is truck B. So truck A is leaving, and for 2 hours gets out this far. So let's pretend that that's 2 hours, and the arrow represents the distance traveled. So after 2 hours, then truck B starts out. So truck B starts out after 2 hours. So as truck B is traveling, like this, truck A is also traveling. And truck B has to have more speed than truck A in order to catch up. So they keep traveling and they keep stretching it out. They get, notice now what I'm doing. So finally, it says, truck B travels for 6 hours at a speed of 40 miles per hour faster. So if truck B travels for 6 hours, truck B for 6 hours is right there. But at the same time truck B is traveling, truck A is also traveling. So truck A is here, truck B is here. So truck A is traveling for 6 hours also. At the same time truck B is traveling. But that means that A is traveling for 8 hours, because it's 2 hours to start at the beginning plus the 6. Truck B only traveled for 6 hours. And the distance, if you think about that, the distance is 60 miles difference. So we get to that in the equation now in a minute. So the rate times the time for truck A is 8A. And the rate times the time for truck B is 6B. So it says that they traveled 60 kilometers further. Truck B is 60 further. So if truck B is 60 further, then 6B is the distance of truck B minus truck A, which is 6A, because that's the distance, and the difference is 60. Remember, the speed of truck B is 6B. The speed of truck A is 8A, and truck B went further, so the distance of truck B minus the distance of truck A gives you 60. And it says that truck B traveled for 6 hours at 40 kilometers faster. So truck B and truck A speeds are B and A, but truck B is faster. So I'm adding 40 to truck A. Truck B is faster. So I could go B minus A equals 40. But I went with B equals A plus 40. So I added 40 onto the speed of the truck A to get the truck B. And the reason I did that because I'm going to do a substitution here. I'm going to sub much. I'm going to sub A plus 40 for B into, and again, let's call this one number 1. Let's call this one number 2. I'm going to sub this into number 1. So let's write down number 1. There it is. I'm going to sub in A plus 40 for B. So A plus 40 is going into place of B. Multiply, I get 6A plus 140 minus 8A is 60. So let's go up here. Now I get 6A minus 8A equals 60 minus 140. Notice these two stay the same. The 240 is coming over to become negative. I get a negative 2A equals a negative 180. Divide by negative 2, and I get A is equal to 90. So if I got A, if I sub A in here, I got to work with the B, solve, move it. This is the better equation because B is already by itself. So I'm going to sub 90 for A into number 2 equation. And number 2 equation is B equals A plus 40. So A is 90, so B is equal to 90 plus 40. So B is equal to 130. So we have two speeds. Truck A is going 90, truck B is going 130. So truck A is 90, and we have what? Miles per hour. Miles per hour. And truck B is 130 miles per hour. You could just say one truck is going 90 and the other truck is going 130. But check it out. If you check these out and check it in here, well, obviously that's where we got the answer from. So 90 plus 40 is 130. And if you multiply 6 by 130 and 8 by 90, you get a difference of 60. So that brings us to the end of this video. If you like my video, click the like button, click the subscribe button, click the notification bell, and visit my website at www.mathsfullyexplained.com to find more information about me, video, and the content on my YouTube channel. And remember, the charts we're using is very important. Hope you enjoyed my video. Thank you very much. Bye-bye.